Good morning. We're going to work on the normal distribution today, and we're going to be calculating probabilities or areas or percentile ranks. Please remember those are essentially interchangeable. And this is page 100 of the note spiral, and we're going to be using a table to do this work. And I'm going to show my work on a separate sheet of paper. So it says, what's the probability that a light bulb will last less than 1410 hours? Well, I probably should read my scenario first. The scenario says the life expectancy of a particular brand of light bulb is normally distributed. Okay, because I can only use the tables if we're working with normal, with a mean of 1500 and a standard deviation of 75. So I'm going to go ahead and draw that out. So here's what we have. Our center is here at 1,500. So we have a mean equal to 1,500 and a standard deviation of 75, and they told us it was normal. If I wanted to, I could sit there and draw standard deviations out, but I'm not going to. And it says, what's the probability that it'll last less than 1,410 hours? So right here, somewhere below 1,500, somewhere below 1,500 is 1,410. And since it's less, I'm going to shade it that way. And I'm going to write it like this: the probability that some value x is less than 1,410. That's what we're looking for. So if I go ahead and set a z-score up, it's going to be z equals x minus mu over sigma. All right. Well, in this case, we know that our mean is 1,500. We know that we have a standard deviation of 75, and we also have an x value of 1,410. I'm going to see if I can pause this for a moment, see if I can't do something about these shadows. It doesn't look like it did much good about those shadows, but we end up with 1,410. So this is our z-score. And so I'm going to go ahead and calculate that out. And 1,410 minus 1,500. I'm going to divide that by 75. And I get a negative z-score, a z equal to negative 1.2. So I want the probability that z is less than negative 1.2. That's what we're looking for. All right. And it's no surprise that we're working with a negative z-score because we're below the average. 1410 is below the average. So at this point, I can go to my table. And since it's negative, I need to make sure I'm using the negative table. And I'm just going to look up negative 1.2 and go, okay, my answer is 0.1151. All right. So equals 0.1151. All right, that was part A. Let's move on to part B. Part B says, what's the probability that the light bulb will last more than 1,583? Now, this is a little bit trickier question, all right? A little trickier question. So we're looking at still looking at the same curve. We still have a mean of 1,500, but now we're looking at 1,583, and it says more, so we're shading up. We're shading up. Please don't forget our standard deviation was 75. All right, so we're shading up, so we're going to be on the positive side, so we're expecting a positive z-score. All right, because 1,583 is above that. So here we go. Z equals x minus mu over sigma. And what I should write is the probability that x is greater than 1,583. That's what we're looking for. Plugging into the formula, I end up with z equals 1,583 minus the 1,500 divided by the 75. I go to plug that into the calculator, and it's 1583. Don't know if y'all can see that or not. Minus the 1500 divided by 75. When I do that, I end up getting about 1.11. All right. So this is approximately, so I'm ending up with a z-score equal to 1.11. So I want the probability that z, and which way did I shade? I shaded up. So I want the probability that z is greater than 1.11. So first off, let's look up 1.11 on the z table, all right? So when I look up 1.11 on the z table, I see a value of 0.8665. I see a value of 0.8665. So this equals 0.8665. That's incorrect. The probability that z is less than 1.11 equals 0.8665. So if I want the probability that it's greater than that, or that it's above it, I'm going to have to subtract from 1. So 1 minus 0.8665. I'll explain that in just a second. Equals 0.1335. Now here's what happened here. Remember, the table always works from left to right. It always works from left to right. So when we did this, and we got a z-score of 1.11, it found that area. That's what it found. And it said that was 0.8665. But we did not want that area. We wanted this area shaded in blue. So since this was 0.8665, I had to subtract that from 1 to get this part. And the reason I subtracted from 1 is because I knew it was a valid probability distribution. And so if everything down here was 0.8665, then what was above it was the rest of it. So 1 minus 0.8665 gives me my answer of this. And here's the way I would like to state it. The probability that z is greater than 1.11 equals 0.1335. Or you could say the probability that x was greater than 1,583 equals 0.1335. Now I'm going to stop and make a separate video for the rest of this.